All right, ready? So here's a little information. So some of you, when you email me, you say, I don't get any of this. And then, and I get it, but I'm also happen.
It's like you get it, but then
I didn't do anything. You know what I'm saying? You know what I'm saying? I swear I didn't do anything. You're the last one to touch it.
Oh, there's some broken. Start blaming me, pal.
Oh, there's two.
Yeah, look at that. Huge. All right. Let's just make this all the way.
That's creepy.
All right. Yeah. Cool. So, so I was saying, some of you email and say, hey, I don't get any of this. And sometimes when you show me stuff, it's like you kind of like maybe put your name at the top, and that was about it. Good for you. If you were to do anything in life, such as any hobbies or activities, and you didn't get it, you still tried something. You had some sort of maneuver that did take place before you said, okay, I need help. But some of you, like, literally, you look at number one, and you're like, dude, I'm done. Okay? And so that concerns me a little bit, because I promise you, and I promised you yesterday, nothing would break if you tried something. And again, homework, I'm not looking for it to be accurate. That's your practice. Okay? My daughter, her name's Leah, she's in 8th grade. She's been playing piano since kindergarten. She is unbelievable on the piano. But she didn't sit down at the piano and start playing just like, oh, this is easy. She had to learn. She goes through lessons, and now she does a lot of competitions and does play in front of audiences often. Okay, she's very accomplished. Now, I'm not the parent saying, you will learn piano. Okay, we offered the opportunity to my kids. My youngest daughter felt that after a few years of playing piano, it wasn't her. I wasn't going to force her to continue it, but my oldest will play piano. I'll get home, and she will be playing piano nonstop. She just loves it. And I love it. I love it too. So but she practices and practices and practices. So she doesn't get to a piece of music and says, I don't get it, and just closes the book and calls it good. She opens it up and says, okay, well, I think this piece, I'll start with my right hand. Okay, I get that. And then she goes through the rhythm with her left hand. Okay. And then she starts putting it together with both hands. So my point on this is, persevere through the anxiety of math. Okay, push through it. Try it. I swear, I'm not gonna be that guy going, dude, you put a color for an answer. You're a moron. I'm not that guy. And if I've conveyed that to you, I'm sorry. But it's hard for me when nothing has been tried, and then you come to class with a blank sheet of paper other than your name at the top. Same thing. My younger daughter, she plays soccer. Now I'm going to tell you that she enjoys the game of soccer. In no way, shape, or form is she going to get a college scholarship for soccer. She's not going to be in the Olympics. She's not going to be paid to play soccer, but she enjoys soccer. And I've coached her for quite a few years, and she has a pretty nice team of kids. We've got great parents. Yeah.
The question is, was she better than Eddie?
Yes.
Okay. As
Yeah.
in, like, soccer-wise?
Yes.
Okay.
Yeah, because she could use both feet and she could dribble the ball.
Okay.
Eddie honestly couldn't dribble. Like, he would dribble the ball like this. I understand when no one else is out on the field. He's trying. I get it. But when there's other people out on the field, 10 or 11 other people who are going to try and take the ball away from you, that's not the fast way. So, but I will tell you this, Reese. At practice, she won't try as hard as Eddie, ever. Does that make sense?
Yes.
So Eddie's try mentally was he would put so much forth in every drill to try and make it right, but it was slow. But yet he scored later in life. He scored in a game, which is awesome. So that's the long and short of it. All right, so again, I don't see any problems written on the backboard, so that either tells me you forgot about that practice or you're just afraid to go back there because you're getting made fun of. So take a look at number 1, number 2, and number 3. Number 1 has an answer of 8. Number 2 has an answer of 5 square root 2. And number 3 has an answer of 6 square root 2. Are there any of those, 1, 2, or 3, that you would like me to go over? Go ahead. Number 2? Perfect. The problem number 2, it's square root of 50. Now I'm going to put over here to the side. I know that I have some of these perfect squares. And that's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, so on and so forth, right? So what I want to do is first thing I want to approach is going, can I break 50 down into one of these numbers and realize 1 doesn't really matter because 1 times 50, of course, is 50, okay? So which one of those numbers up there does 50 appear could be something times one of those numbers? 25. Does that make sense? Now, that's not always the simplest way to go, but we're going to just try this. And I know if I do this, I'm going to get this. And then I know I'm going to get this. And then in math, we don't want to have that last. We're going to change the order of it. So we get that. What do you think?
So is that the answer?
Yeah, done. Yeah. Yo. Are you waving at me? No? All right. Anything else from 1, 2, or 3? Yeah. And I'll tell you on number 3 is going to be the same thing as 36 times 2. And so make that work with that if you didn't get number 3.
I think I did one different.
Same answer? There's a lot of different paths that'll get there. So good deal. So let me go over number 4. Number 4 is going to be 2 square root 3. Number 5 is 108. Let's do number 5. Number 5 might not stick out real easy with us on this problem. So here's where things start getting mixed up, and it mixes up my head too. If I don't see right away a number times 108, or a number times something gives me 108, I'm going to go to a different route. Okay? So I know that if I break 108 down, that's the same thing as 2 times 54. Now, some of you are sitting there going, yeah, but 54 isn't one of those numbers. You're exactly right. You're exactly right. So let's go a little bit further. I can't break 2 down any further. But can I break 54 down as 2 times something? 2 times what? How much? 47 or
27.
27, okay. I like that. I can see that. I understand where this math is coming from. So I can't break 2 down any further, but I think I could break 27 down. And 27 is going to break down to 3 times 9. Why did I not go 2 times something gives me 27? 2 doesn't go into it evenly until it becomes a decimal. Okay? And then I have to realize that this is the same thing as, I don't know why my board's being slow today, but we won't judge. Okay, so hang on a second. So what I'm saying is, if I were to take 2 times 2 times 3 times 3 times 3, I would get 108. Hang on, let's make that work. Someone have a calculator. Let's make this work. Go 2 times 2 times 3 times 3 times 3. Enter. And it gives me 108?
Yeah.
Okay, so this is something that sometimes in some elementary schools are going to teach you, some they're not. This is basically the prime factorization. We broke the number down into its prime components. If you remember the term prime, a prime number is a number that can't be broken down any further. Yeah.
You always had to break it down into 2 parts because I broke it down into 3.
No, you'd be okay.
Because I got 3 square root 6, because I did 36 times 3.
Okay.
I got 108.
Gotcha.
So is that right?
So 36 times 3 is 108. So you saw that right away.
Yeah.
But you're probably one of the few that saw that right away, which is great. You're going to get the same answer as us. Watch what's going to happen. Okay? So let me ask you all this. What number technically is right here that we just kind of ignore because, is it 1? 2. 2. Right? So this is technically the square root, and we would have a 2 all the way through. Do you agree with that? Now, we don't write that because the square root is the most basic form of roots. So we as people are like, oh, because that's the most basic, we don't have to write it. It's already assumed. And you're like, really? I think if we would have written it all along, we would have been fine. So this is what this means. I'm going to look for pairs. Okay? So here's a pair of numbers. Do you agree with that? Here's a pair of numbers. Do you agree with that? That last 3 can't be paired with another 3, can it? God bless you. Are we okay? All right. So hang on. I think I could do this. This right here is the same thing as square root of 4. This is square root of 9. Can you make that work in your head? Can you make that work? And I'm taking way more steps than I need to, but I want to break down the necessity of this. Okay, so what's the square root of 4? 2. So if I take the square root of this, what is my answer? 2. Where did the radical go? I did the math operation. So square root of 4 is 2. What is the square root of 4? 2. So I know a lot of people will go, oh, square root of 4 is square root of 2. No! The square root is going to be the operation taking place. So what's the square root of 9? 3. What's the square root of 3? Irrational. Leave it. So if I were to multiply 2 times 3 together, I get 6. And so I get 6 square root of 3. So if you sound like Mr. Summers, he realized that square root of 36 times 3 is 108. And the square root of 36 is? 6. So 6 square root of 3. So if you see the trick early, you'd be like, oh, this times 2, or this times 3 will give me 108. But if you don't see it real quick, break it down into its parts. And if we're doing square root, you're looking for pairs. Pairs of primes. Okay? Another way people do this is, what will that give me? Yeah, 2. And what will that give me? And then that'll come down. Yeah.
We're going to have a calculator for the test.
Oh my gosh, all day long. I mean, you should get one if you don't have one. And no, I'm not going to let you use your phone on it. If you don't have a calculator, come visit me over there. I think I got a couple stashed in my drawer that I've inherited that you can have. Can I clear? Okay. Number 6 is 96. Okay, square root of 96. So let's think about this. Square root of 96. Let's make this work. So I know I have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Right? Okay, so let's see if we can see this right away. I'm going to ignore the 1. So what times one of those numbers is going to give me 96? I can eliminate the 100. I can eliminate the 81. 64 is pretty easy. What about 49? Oh, that's 98. So I'm going to ignore these right now because they're not going to work for me. Why is that? Well, 2 times some number is going to give me 96. And I think it's 2 times 48. And being 49 is bigger, we can not do that. What about 36? Is like 2 times 36 or 3 times 36 96? I don't know. I can't do it in my head. What about 25 times some number? Is that going to give me 96? No. What about 16 times some number? Maybe?
16 times 6.
How much?
Times 6.
16 times 6? Really?
Wait, hold on, wait.
I don't know. Maybe. You might be right. Yeah? So, if you went through this list, you would realize that 16 times 6 is the same thing as 96. And so, I could break this up into this. And I don't know what the square root of 6 is. I know it's irrational, and I'm still not quite sure what irrational means. But that just basically means if I do the square root of 6 on my calculator, the whole screen is filled up with numbers. Okay? But I know what the square root of 16 is. What is that? 4. Done. A little easier? Starting to make a little sense? Okay. So number 7, the answer is 3 root 3, or 3 square root 3. Number 8, the answer is 4 square root 3. And number 9, the answer is 5 square root 5. Are there any of those, 7, 8, 9, that you would like to see? 7, 8, or 9 you want to see? Yeah. Number 9, absolutely. Okay, so number 9. And that's a great one to think about because, you know, when you start getting into triple digits, it's like, okay, I'm not seeing numbers coming at me like, whoo, there it is. Okay, and if I'm not seeing it, you might not be either. So what I'm going to do is I'm going to say, okay, can I break down 125 a little bit better than what it's at? I know 1 times 125 is 125. I know 2 doesn't work because it's not an even number, right? 3, this is where you have to start remembering the rules of math. If I sum up 1, 2, and 5, that gives me 8, and 8's not divisible by 3. And you're like, how in the heck am I supposed to remember those rules? Okay, so someone, if you have a calculator, go 125 divided by 3. And if is it a whole number or is it a decimal? Decimal. Okay, let's not do 3. 4 isn't going to work. If 2 doesn't work, 4's probably not going to work. Does 5?
Yes.
5 times what? How much? 5 times 25 is 125? Hey, what's cool about one of those numbers? It's a perfect square. So what is the square root of this? So my answer is 5 root 5. Done. Okay? The step that took place here is root 5 times root 25. Root 25 is 5, so I got this. And then I rewrote the order of it. Huh. That help you out? I forgot who asked that one, but whoever did I help you out? Oh. People are yelling outside.
Yes.
Let's see. Number 10, the answer is 2 root 5. Number 11, the answer is square root of 49, and square root of 49 is 7. Good, good. Number 12, I get square root of 60, and I'm stuck. Hang on. So on number 12, is everybody okay getting to the point where I get to square root of 60? The square root of 6 times the square root of 10 means the same thing as the square root of 60. We good there? Okay. Which one of those numbers other than 1 times some other number will give me 60? 4 times what? 4 times 15. Yeah, buddy. So 4 times 15 gives me 60. Does that make sense? Now, a lot of you are going, gosh, how are you getting those numbers right away? Well, I'm going through those perfect squares. If I don't see anything right away, I think if I start with a 4, if I go 60 divided by 4, you're like, sweet, it works. You can stop there. Now, is it always going to be the perfect answer? Sometimes this could be broken down a little bit further, but what does 15 break down to? It breaks down to 5 times 3, and both 5 and 3 are prime numbers which can't be broken down. So 15 can't break down. But what is the square root of 4? So I get 2 root 15. Okay. Then number 13, the answer comes out to 11 square root 2. And I'll just do the next 2. Does anyone want to see number 13 worked out? It's okay if you do. Angela, yeah? Sweet. All right, can I clear these? Clear ink. Number 13. This is one, it seems a little weird. You're like, wait a minute. Now, so technically, this is the same thing as 242. Right? And I pretty much know for a fact that going through 1, 4, 9, 16, 25, 36, 49, 64, etc., I definitely am not going to see that right away. So you know what I'm going to do on this problem? I'm going to, I realize that this times this gives me this, and that's great, but I'm going to do this. Do you agree with that? That's not too tough, is it? Does 11 break down any further? No, 1 times 11 is as far as you can go. What about 22? Does that break down? Breaks down to what? How much? 2 times 11? Hey, what number are we always forgetting about right there? 2. I'm looking for pairs. Do I have a pair of numbers up there? Yeah. This times this is 121. So 11 times 11 is 121. What is the square root of 121 then? 11. Okay? So this could be rewritten as 11 square root of 2. Could I put the 2 right here? Sure. Is it right or wrong? Yes and no and maybe. Okay? So the answer to problem number 13 is 11 square root 2. But please realize, I didn't go through this number here to establish this from this list. What I did was I realized this is awkward. Let's go from this. This 11 is the same as this 11. This 22 is the same as this 22. This 22 breaks down to this. This 11 comes straight down. And then I look for pairs. Okay? So that's going to help us with number 14 and number 15. Can I erase this one? Actually, I can probably squeeze here. That should be all right. All right, 2 square root 6 times 4 square root 12. Okay. So if something's outside, I'm going to multiply that with something else outside. So I'm going to multiply that and that to get that. Is that okay? And then I'm going to realize I have this. Now I can go ahead and multiply 6 and 12 together. 6 and 12 multiplied together gives me 72. Right? But I don't know if that's the way I need to go necessarily. You know what I think I can do on this problem? That 8 is pretty happy. If anything comes outside, 8 is going to be multiplied times it. You still with me? That makes sense? All right, so let's start breaking things down. In no particular order. Let's break 6 down. What does 6 multiply together? It is 1 times 6, but what else is it? 2 and 2 is 4. 3 and 2. 3 and 2. Yeah. So 3 and 2 is the same thing as 6. Okay? Hey, can I break 12 down? 12 is 1 times 12, but what else is it the same thing as? How much? 3 times 4. Or, some of you are going, what about 6 times 2? Whichever way you choose, it's going to be right. So let's break this down. If I choose 3 times 4, here's the nice thing with 3 times 4. 3 can't break down any further, right? What does 4 break down to? 2 times 2. Okay? So what number's out here that I'm forgetting about? I kind of ignore this. That means I'm looking for pairs of numbers. When I find a pair of number, if I take a square root of a pair of numbers, it's just that number. Okay? So, I have this and this as a pair. What is the square root of 3 times 3? 9. Well, 9, but what's the square root of 9? 3. So, this 8's coming down. I took the square root of 3 times 3, which is 9, which gives me a 3 outside now. Sweet, now that 8 and 3 are going to multiply together. Do I have any other pairs of numbers up there? Yeah.
2 and 2.
2 and 2. Does it matter which pair you pick?
No.
No. Don't pick that. What's the square root of that? 2. It's 4 when you multiply, but the square root of it's 2, right? So then I have a 2 outside. What do I still have under the radical sign? 2. Okay, so let's do the math. 8 times 3, 24. 24 times 2, 48. Good. 48 root 2 is that answer. 48 root 2 is that answer. Heck yeah. You're over here starving, you're like gnawing on your fingernails. Oh, good protein. Alright. Yo.
So I'm still like trying to understand like why would we need to do the like for number 13 what we did there if we could use the calculator. I mean for the test and stuff.
Okay.
Because I found it like 121 divided. I mean 121 is the divisible by 2.
Yes.
242.
Yes.
And then you get you square root that you get 11.
Yes, you're absolutely right. And that is totally a great path. And I think you're seeing it that way, and I completely urge you to continue doing it that way. Okay? But a lot of other people, they don't see it right away. Like, a lot of times, I'd say over half this class right now, and this it makes them normal. If you take any arbitrary group of kids or people, they don't see numbers right away. Like, they don't see the pattern of, oh, 16 times whatever is this. It's not, it doesn't come fluid. And it's not because they're broken. It's just that their brain, their synaptic response goes from here to here, and yours is going from here to here. And it makes you normal, and it makes them normal. But they might have to go from here to here to here, and you're going from here to here. Totally perfect. Everyone's perfect. It's just thought processes are a little different on everyone else. You remember in the beginning of the year, I told you all math really is a way to make you to think. Okay, and so it's a logical progression of events. Sometimes that logic takes a little longer for some people. Doesn't mean they're broken though. It just means that they don't see that pattern, that string of events that quickly.
So
it's
like
fine.
teachers don't really care either way you do it. Like I thought if they wanted me to do it that way, I would have to learn it that way.
No, sir.
Okay.
I feel if you're matching up your answers to my answers, your thought process is also correct.
Okay.
Cool? And if I ever make you feel different, please let me know. Now, the thought process that I don't really necessarily like is the one where some person does the work and another person assumes that the work that's on that paper is also theirs. I don't like that thought process. But that is a thought process. But, I don't think it's the right one always. Should I do number 15?
No.
Or is everyone locked in going, dude, I'm there? All right. So here, I'm going to teach a little lesson. And I'm not necessarily going off. But what I'd really like to do is, my gut feeling tells me that 16 through 21, we're not necessarily done to the best of your ability. So with what you know now, let's make sure that gets focused on as a portion of tonight's homework. But can I teach a little bit? And I'm going to promise you all this. What I'm going to teach you today, in no way, shape, or form, is going to be harder. In fact, most of you are going to make that leap right today going, oh my gosh, I totally see it. Okay? You trust me? We good? You ready? Can I clear this? Do you need to stretch? Do you need to slap your neighbor who's sleeping? Slap him. No, not real hard. All right. Ready? Ready? Set? Let's shave his eyebrows off next time. Or shave one of them. I'll be like, dude, what's going on? Be awesome. I can tell you what that means if you want to know what it means, but I'm not going to tell you on camera.
What does it mean?
If you know what it means, come talk to me over in my office. Again.
What does it mean?
Again, ready? Set. Ready? Set. In 3, 2, 1. Okay, here we go. All right. Does anyone feel that could be broken down any further?
Yes. I mean, is that a capital X, and can we multiply it by little x?
No. The little x doesn't give us a capital X and multiply. But I like your thought. That's kind of fun. So, if I were to break x down, the only thing that x is 1 times x. Yeah.
So X is the 23rd letter in the alphabet. Is that code?
Dude, I like it. And 23 is prime, and you can't break down a prime number, so I guess it's not going to work. 3. Oh, man, he went quick. Got fast on that one. All right, so this and this are the same thing. And theoretically,
That's because they are the same.
now if I put a little 2 there, are they? What?
No, it's not the same.
What do you mean?
No, it's not the same.
Why?
They don't look the same.
Because we as Americans are lazy. We don't want to write the little 2 under above the check mark.
Yeah.
Right? I understand. So square root x and square root x are the exact same thing. Now, hang on. Shh, shh, shh. Watch. Ready? What is x squared the same thing as? X times x. So this is the same thing as x times x. Still with me in this adventure?
Yes.
And when I'm doing the square root, I'm looking for pairs. So do I have a pair? That's a pair. So what is the square root of x squared?
X.
X.
Wow.
Yeah. Done. Okay. Hang on. I think I got a pattern figured out. Okay, so this doesn't break down. This breaks down. Okay. Oh, this is heavy. Here's that word again. Walk me through. What is this the same thing as? X times x. And being I'm doing a square root, I want what? I want 2 of a kind. Do I have 2 of them in there? So what is the square root of that? X. Do I still have something inside? X root x. X root x. No. Why? So x to the third is x times x times x, right? And being I'm doing a square root, I'm looking for pairs. A pair of x times x. So so basically, this is breaking down. So this right here is the same thing as this. And that's what's taking place. Cool? All right. Can I go a little further? We ready? Oh, man, we got 11 minutes left. Dude, I can make it. Can I clear?
Yeah.
3, 2, 1. Got it. All right. Hang on. Let's see. Okay. Perfect. Oh, sweet. Okay. All right. Can we take a leap of faith? Oh, this is going to be good. I'm excited.
No.
Yes.
This is good.
Yeah.
You ready?
Am I gonna die?
Yes. But we all do, so it's okay.
Eventually. Well,
I just pretty sure that we all have a little bit more than the next second of our lives to live. I'm pretty certain about that. If not, I can do chest compression so I can keep your blood circulating. And,
so technically you'll
But I
be
don't want
alive.
to die.
even
Well,
if-
I understand.
even if your brain
No, but in math, I know.
I
You know,
would die eating a piece of cake.
Insane.
I'll go with that. All right, you ready? You ready? You ready? With me? Here we go.
Jazz hands.
Jazz hands. No, these are jazz hands.
Jazz hands?
Not like anything special. To be insane.
Holy moly!
Too big.
I think we can do it.
Oh my god.
Who's with me? Who's with me?
I can do it.
All right. So first thing I want y'all to realize is I am multiplying 3 radicals together. So I have
Would you combine like terms?
I will. What do you think?
18 times 2 times
Yo.
6.
Could you combine?
Yes,
18 up-
we're gonna get there.
Okay, well,
We're totally gonna get there. You ready? All right. So I had 3 radicals all multiplied together. I just put them all under 1 radical. All right. Let's break 18 up. 18 is the same thing as 2 times 9, and 9 is the same thing as 3 times 3. Okay, that's good. X to the third is the same thing as x times x times x.
Yes.
And why is that? Is that okay? All right, next one. Can I break 2 down any further? No. What's x to the 4th?
X times X times X times X.
X times X times X times X. And what's y to the 5th? 1, 2, 3, 4, 5. Woo!
So done.
No, I'm not done yet.
Give up.
I'm close. All right.
Give up.
All right, Brenna. 6 is the same thing as what?
2 times 3.
Oh, it's not.
Your voice got so much deeper, Brenna.
My voice?
I said, what's 6 break down? And I heard, and you threw it. You're like ventriloquist. All right. X to the 4th. How do I write it?
X times X times X.
Brenna is a magician.
1, 2, 3, 4. Y to the 7th is 1, 2, 3, 4, 5, 6, 7. Still with me?
Yes.
Holy cow. Okay, shh, hang on. We're gonna get here. Ready? All right, ready? Square root means I'm looking for pairs. With me? No, he has nothing to do with this yet.
Oh.
I Jesus ain't for saving this time.
Prayers are always welcome. You know that. Okay. Hey, I have a pair of 2s. So what's outside?
2.
No, inside's 4. So what's outside?
2.
2.
Oh.
Still with me?
Yeah.
All right. Still looking for pairs.
Oh, what about 3 and 3?
I have a pair. So what's outside?
3.
Times 3. Okay. I'm looking for, do you have any more pairs of numbers?
X.
The Y.
No, numbers.
Oh.
Nowhere. All right. Here we go. Ready? Let's start counting. This and this gives me
2x.
x squared. So what's outside because of that?
2x.
X. I'm looking for another pair.
There's another.
What's giving me there?
X.
What gives me this?
Another X.
Here and here.
Another one.
Another X.
Here and here.
Oh my gosh.
Still with me? Shh. Down to the y's. Still with me?
Yes.
So I'm going to eventually multiply these out, but not yet. Looking for pairs.
Y.
Y.
So what does that give me?
Another one.
A y? What about this?
2y.
What about this? What about this? What about this? What about this? What do I have left inside the radical as far as numbers?
X and Y.
2 and a 3, which is 6. What else?
X.
Y.
I have an x and I have a y. Okay? Under the radical's done. Okay. All right, here, let's do this real quick. 2 times 3. 6. X times x.
X.
X squared.
Times x.
2.
Another x.
4. 5th.
X to the 5th is outside. All right, shh.
X
Here we
is
go.
6.
Y.
I mean Y.
What?
Y
There's
is
2. 1, 2, 3, 4, 5, 6. Y to the 6. And then my radical. Oh my gosh, this is so cool. So that's like really hard. That's the hardest thing all day long.
Do we have one of those, please?
No, you don't even have one that big.
Sarah,
Yo!
see something weird?
No, not yet. But I'll be back. So guys and girls, shh. On page 44, I want to make sure you had 16 through 24 done correctly. Okay? So I'm thinking you can do it with what we've gone over. And then worksheet number 21 is just 17 problems. It's one page. So that's 21B. Worksheet 21B, which is just page 45. Okay? So, who needs copies? I know Ray does. Anyone else need a copy? You need a copy? That's 2. And I'll get you some copies. I'll bring it to our next class.
0.
Okay, well, I gotta write this down.
Just do it. It's easy.
Hey, if you need a copy of the next couple pages, come up here and print your first and last name on this card so I can get it to you. There's a card up here for your first. If you need a copy of the next couple days of worksheets. Come print your first and last name on this card, and I'll make sure I get it to you today.
Do you want to help with basic math for 7?